Welcome, everyone, and thank you for joining the third and final webinar of the CASE NCSEA SEI Joint Summer Series on Artificial Intelligence. Today's presentation is by SEI on AI developments that will shape the practice of structural engineering. Our moderator today is David Odeh. David is a structural engineer with over 30 years of experience in the design of complex buildings. He has particular expertise in the applications of digital design technology in structural engineering. Based in Providence, Rhode Island, he leads the building structures practice for WSP in the US. At this time, I will now turn the floor over to David to introduce our presenters.
Hello, everyone. I'd like to thank all of you for joining us here today in this last week of the summer before Labor Day. I know many of you have taken the time to engage with us on this important topic, so thank you for being here, and we've got a great discussion for you today. The first thing I'd like to do is introduce our panel who's going to be speaking to you about this important topic. Today we have some really distinguished speakers who will be talking to you about the topic of AI in structural engineering. In particular, we're going to be focusing today on how this technology, this sea change, is going to impact our profession and our workflow. So first, we have MZ Naser. MZ is an assistant professor at Clemson University in the School of Civil and Environmental Engineering and Earth Sciences. And he also is part of AI Rise, the AI Research Institute for Science and Engineering at Clemson, which sounds super cool. So we're going to hear about that from MZ today. His research group is creating machine learning methodologies to discover new knowledge hidden within the domains of structural engineering and material science. He's also the chair of the SEI Advances in Technology Committee. Our other panelist today is Kristopher Dane. Chris is an associate principal at Thornton Tomasetti. He's a former chair of the SEI Digital Design Committee, and he has deep experience leveraging technology to address building design challenges. And he's spearheaded substantial design technology transformation initiatives in top design firms. He now leads the protective design practice projects at Thornton Tomasetti. And he also probably has what I think is one of the coolest jobs in structural engineering. He oversees TT's internal research and development grant program called the Core Lab. And we'll also hear some about that, I'm sure, today from Chris. Next slide, please. So as we start this out, this presentation, you're about to see a poll come up on your screen. We would like to engage with you, the audience, a little bit, just to get a little bit of a sense of who we have in the audience, what your experience is with AI in your workflows. Are you using it in your firm or your daily practice? And then what best describes your personal use of AI? So if you could take a couple of minutes, a couple of seconds here just to fill out the poll questions, this will help us and define a little bit who the audience is, because we would like this presentation to be interactive. So while you're finishing that poll, I just want to give you a brief overview of what our plan is today, an outline for what we've got in store for you for the next 15 minutes or so in the presentation, and then I'll turn it over to the speakers. CASE, NCSEA, and SEI have come together to produce this summer webinar series, and this is the third in the series. And I think it's so great that the structural engineering profession has unified around really trying to discuss and talk about and address the challenges and the opportunities that AI and the associated technologies are bringing to our profession. So we heard from some experts in the first session from NCSEA in June on a lot of the tools and specific technologies that are out there. I know I learned a lot from that first presentation. Then last month we heard from Case and how businesses and firms are introducing AI into their strategic plans and building it into their businesses. Today we're going to take a little bit of a different track, and that is specifically looking at how this impacts the profession. How will this impact our workflow, and how will you, as an engineer or researcher or scientist, leverage these technologies to change our profession, to change our workflow? So we'll start off with some introductory remarks where Chris will lead us through a little bit of level setting, just to talk about how where we are at, so that we're all on the same page and some of the terms we're talking about and technologies that we'll be discussing. Then we'll roll right into a panel discussion with Chris and MZ and me, talking a little bit about some questions. And last, we'll take some of your questions and we'll give them to the panel and talk through them together. So with that, I'm going to turn things over to Chris Dane so that he can kind of level set us and give us some introductory remarks. Chris?
Thanks, Dave. Perhaps just before we move on, can we see the poll results? Just pop them up on the screen and get a sense of who's in the room here. All right, that's great. So we've got a good distribution of sort of folks in their career. Nice little bell curve action going on there. And some educators, that's good. MZ is happy to see that, I'm sure. And then on the question, has your firm started using AI tools? For those of you who attended this second webinar, I guess this distribution won't be a surprise. The sort of not yet but planning to. Lots of folks thinking about this. Hopefully, this webinar series has been useful in helping inform the plans, and that this conversation today will help provide some guardrails on that. And then this next question was sort of intentional to draw a distinction between what our firms are doing versus what we're doing as individuals in our work, and to see if there's a difference in that distribution. So here you can sort of see that folks are using kind of experimenting, heavy experimentation in half the room. Not surprising, given that we're in a AI series. Quarter of the room curious, and then a quarter of the room using it daily. Very good. All right, excellent to see. Thank you all for participating in that. I'm sure that everybody here, whether you're informing your firm's plans or whether you're looking hard to move from curious about how to use AI or move up, you'll be armed with some things to think about and some resources after today's discussion. Thank you for that. All right. So as David mentioned, this is the third in the summer series on AI. He did a great job summarizing kind of the themes that were drawn out in each one. The first series arms you with a whole collection of tools that you can deploy in your work. The second in the series had a robust conversation of how to think about strategy and how to deploy AI in your firm, and the connection between your business strategy, your data strategy, and AI, and how those work together. In this conversation today, we're really thinking about how does this fit in the broader sense of the industry, and how does it inform standards, and how does this fit within the context of structural engineering writ large. We'll drop some links to the previous webinars in the chat. If you didn't have a chance to watch those, they're available publicly, and I really encourage you to do that. There's just excellent information in each one. the content of this discussion is also based on an article that was released in Structure Magazine this month, and here's a quick QR code. We'll share the link to this in the chat as well. Titled "Transforming Structural Engineering: Embracing the AI Revolution." It is entirely possible, if you're like most engineers, that your desk might look something like mine in the picture on the left, where you have a pile of industry magazines, and you haven't gotten to this one yet. I'm sure our magazine is on the top with the article in it, and you just can't wait to read it, but you may not have gotten there yet. So what I'll tell you is that the summary of the contents in the article is that we kind of walk through current applications of AI, what's reasonable to do with it today. We talk through some future opportunities, including using AI for sort of code interpretation, right? So in the current applications, we're seeing it being used for building inspection. This is sort of arming drones with AI and using computer vision. We're seeing AI being used for structural health monitoring, right? These are real applications that are happening today, where we're using AI tools to arm us for doing heavy data processing. But we still struggle in our work with parsing multiple versions of code. It's hard to find information that we want. And so we see an opportunity, especially from the code development perspective, and for engineers who are parsing multiple versions of code, to bring AI, especially the large language models, into that process, both on the committee side and on the user side, to help us draw the distinctions between different versions of code. And that might present an opportunity to change how we present them and the way that our younger engineers interface with the code bases. Maybe it changes from being a book to being an industry standard chatbot. And we see there are some tools leaning in that direction. But we also have to be careful when we do this, because there's limitations, right? We need standards to guide this. As we roll out new tools that can design things very quickly, we need to have governance in place, as Mehdi was talking about in the second series in this webinar. And we need to have robust QA/QC around this within our firms, and to guide engineers to make sure that we don't make big mistakes quickly. And in the industry, we need to think about risk exposure, right? Structural engineering is an industry where our mistakes are there on public display, where we hold thousands of people's lives in our hands. And so we need to adopt new tools very cautiously. And as we go into that, we need to have robust kind of governance frameworks around this. And so there's implications on what are the types of standards that we need to vet the tools that are being developed. And furthermore, there are ethical implications around this, including what does it mean when a tool is taking some of the decision-making power out of the hands of the engineer, and what does that mean for conversations around having engineers in? So this is sort of the discussion in the article, and we'll dig more into that in our panel discussion today. Now, AI can be sort of an intimidating topic, and you can find yourself just having vocabulary thrown at you that causes your brain to shut down a little bit. So I want to share this graphic that places some terms into context. So what this graphic shows is that AI is a wrapper for multiple terms, including machine learning, including deep learning, and including, arguably, bits of data science. In our article, we talk about the graphics, or the terms in orange, machine learning, natural language processing, and computer vision, and you can see how they slot into this AI onion graphic. Machine learning is really about improving performance based on past experiences, whereas deep learning is where the model is adjusting its own internal parameters, right? It's not only looking at past experiences, but it's adjusting the parameters that it's using on its own as part of that experience. So it's getting more sophisticated. And all of this is AI. And the LLMs, those large language models like ChatGPT, like Gemini, like Grok, fit into that deep learning area. Now, for all of us who've been around for a while, we will have done some level of programming, some level of iteration, kind of traditional computational design. and that doesn't really fit in here. If I was drawing it on here, I'd kind of put it off the bottom where it's more sort of iterative design, and you kind of come up with an optimal solution based on that kind of programmatic inputs. So that's sort of where that fits in. And I suppose it's important to note that AI isn't new, right? Yes, it's in the press, and we're getting bombarded with this, and it feels like it happened all of a sudden. But really, the evolution of these tools has been ongoing since the 1950s. There's been at least 2 AI winters where we reached sort of a threshold that took time to overcome. And in AEC in particular, AI has been around, and there have been systems being developed that allowed for sort of expert systems to result in complete designs since at least 1989. And that may be surprising, because where have they been? We haven't had them in industry. And part of it has been limits in computational power and in viability of socializing the systems. And so what has happened recently is that computational power, like thresholds, have been overcome, and the ability of bringing that compute power into your pocket, into your phone, into your firms, and do that in a cost-effective fashion has been overcome with the prevalence of LLMs and with some other tools. And so I just want to say that if you're hearing the AI hype and you've kind of lumped it into this bucket of like, this is just another technology, it's just another tech hype trend, and we don't need to adapt to this quickly because it's not going to happen as fast as CAD. It's not going to change the industry as much as, it's not as transformational as maybe we thought Excel was going to be, or FEA, or CAD, or BIM. I just want to say, and maybe we all know this because we're hearing an AI webinar, but I think AI is different because, one, as I said, it's not new. Two, unlike these previous tools, AI is going to touch every role in a firm, unlike BIM or FEA or the other sort of tools that we're focused on our technical production. AI will touch every aspect of our firms. And three, these tools are driven by factors sort of exogenous to the firms, right? They're driven by influences outside the firm. So everybody is going to be adopting AI tools, and that will influence the environment within which we operate. And we as structural engineers need to decide, how do we respond to that? And that challenges us to think about kind of bigger questions about, what does it mean to be a designer? What does it mean to be an engineer? What does it mean to adopt tools that can think fundamentally differently from how we think and incorporate those into our design tools? Before we get into the panel discussion, I want to share with you a couple of resources that I've read that have challenged me to think along these lines, because I think that this response from the industry and how do we address these challenges is a team effort, right? Anybody who tells you they know what the answer is misleading you, and you should check your sources. So I want to share with you a couple of resources that kind of go from the general to the specific. One is called The Age of AI. This is a book that's really good about outlining the risks, kind of the global risks associated with these AI systems. And it was published in 2021. And what's noteworthy about that is that there are some aspects of this book that even through today's lens feel slightly dated. The second book is called Co-Intelligence by Ethan Mollick. And it operates at sort of the individual context and does a great job of outlining a bit of the history of the large language models, and outlines some principles that include sort of, even if you don't know what to do with AI, you invite it to the table, but that you have to have a human in the loop, right? You have to have like an engineer in the loop when you're working with it. And it's a good reminder that the AIs that we are using today are the worst AI that you will ever use, because these tools evolve so quickly. And I know that I've seen that in my own work. And that we will have multiple ways that we choose. Everybody will have an individual approach to how they adopt these tools into their working life, right? And that you won't just have one. You may have multiple AIs that you work with, depending on the tasks that you're accomplishing. and that those will adapt over time. The third book, The AI-Driven Leader by Jeff Woods, was very recently published, and this kind of operates at the firm context, and I think is a good complement to the second webinar in this series. And it really ties together that if you are a leader of a firm or a leader of people within a firm, or you aspire to do that, this book is jam-packed with sort of tangible steps on how to use AI to help you engage with your AI strategy, and challenges you to think about AI as a thought partner. And when you find yourself thinking, wow, that's a hard problem, that you remember to ask, what can AI do to help me with this? And it's got really excellent prompts on how you can engage with AI, including setting up sort of like personalities of boards that you can meet with, virtual boards that you can meet with to run ideas past. And it's a very interesting book. So it's very practical, and those are good resources. Further, both NCSEA and SEI have pages on their websites that are constantly releasing new content related to AI. When I was putting these slides together a couple of days ago, I even found a video on a panel discussion for future leaders in AI, on the future of AI and civil engineering, excuse me. And it's a fantastic panel discussion that's a good continuation and complement to this series. So I encourage you to track both of those websites for content that is specific to structural engineering. So I hope as you leave this panel discussion today, you can leave with those books in your pocket as you think about larger questions. And with that, I will hand it back over to David.
Thank you, Chris, for that great overview. I think what we're going to do right now is now kind of transition into a little bit of a panel discussion about some of the topics that Chris has just described. Thank you for setting the stage for this discussion. What I'd like to do now is invite Chris and MZ just to answer some questions, high-level questions about AI and its role in structural engineering and our profession overall. And I want to start by asking the question, how is AI affecting your current day-to-day the most? And I'm actually going to start with you, MZ. I'm going to ask you to kind of dive into this as the academic, because I think you may even be closer to the technology and the raw roots of the technology and what it's doing to engineering and to students and to educators, and then where you see it impacting the profession right now. So you want to opine on that?
Yeah, well, thank you, David. Thank you, Chris, for this great question and panel. It's very amazing to see like what AI is doing at the moment. A year ago, I started a course on machine learning, and in my head, I was thinking, okay, let me start this course. I'll see how many students I'll have. I was thinking maybe like 7 or 8 students, and then semester starts, all of a sudden I have like 30-something students. And it was eye-opening because at some point I was thinking, well, maybe I'll have a few students, but now you have like a full-blown class. And this really starts, I mean, I don't know how, but if you look at our classes now, like when I went to class, there was maybe 1 or 2 students that have a laptop with them. Now you go to class, there is like multiple tablets for students, and they know the tools, they know how to use it very well. So the expectation in their mind is this is something they're gonna have to use and learn. And if it wasn't for us, it became a little bit harder for them like to integrate this. So I think what I'm trying to say is it's very hard to see like the next year or two in our industry without fully integrating these tools, because the next generation is actually coming in full blown with this technology.
Yeah, I thought it was kind of interesting in the case presentation last month that Mady did. For those of you who haven't seen it, it's available on YouTube, as is the first presentation from NCSEA. He talked a lot about how coding and the ability to code was really transformational for him as a structural engineer and as a subject matter expert. But that one of the things he thought was really empowering and almost democratizing about AI was that it can do a lot of coding for you. It kind of opens up a whole world of coding. Are you seeing that for your students, MZ? Are they using coding? Are they using AI as a coding tool? Does it kind of unlock a lot of power for them in their studies?
100%. I think this is why I had such a turnout, like a lot of students in the class, because the biggest thing in the class was we're not really trying to teach Python or R. We're going to be using like those LLMs to think and then ask the tool to code for us. So this way we get to use AI, we get to learn the principles, and we don't really have like to spend a lot of time learning to code. I mean, learning to code is I believe it's very advantageous. But like when you think about a class setting, you have only like 15 weeks or 14 weeks, it becomes a little bit hard to throw in a full course on coding when you don't really get to use it as much. But now with like for instance with ChatGPT or Claude, it can practically code very, very well, especially for problems like the ones we do. Like we're not trying to invent new algorithms or something. We're trying to use some data to explain some concepts. So it becomes a little bit easier for everybody to use. Plus, they won't have that, like maybe I don't want to say scare or like worrisome about like learning something new. It's more or less, we're all in the same field. We're all trying to learn together. And this is one tool that can help us overcome like a big hurdle of coding, like right away, right now.
Yeah, I think that's a really important innovation that we're seeing, and it's changing the field dramatically. Chris, what do you think about that? I want to throw it over to you for a second. In practice, are you seeing that that power impacting the day-to-day engineering tasks, the things that your engineers are working on every day? I also kind of as a related question, I thought it was interesting how you pointed out that AI is something that, unlike BIM and other previous technological revolutions we had in structural engineering, this is something that affects everyone in the company. Everyone from the legal reviewers to the marketing people to the administrative folks, writing reports and inspectors. In your practice, what is the day-to-day impact right now? What are you seeing?
I mean, I think it's wide ranging, and the answer depends on where you sit in the firm. I'll talk about my personal entry point, because this is sort of hopefully this is a useful story. But as you mentioned in the introduction, Dave, and you know this because we worked together on the committee, is that I was a former chair of the SEI Digital Design Committee, kind of a technology leader in the firm, a bit of a tech nerd, and I could not wrap my head around what ChatGPT was and why it mattered to me. And I felt it felt odd in my mind. There was a bit of like kind of cognitive dissonance happening even in my own brain around that, but it was like I don't really know why I care. I have real work to do. It was sort of like the conversation was happening in my head. And that was up until I had a conversation with a security mentor of mine, as it kind of was in the process of transitioning into protective design, who was in his 70s, and he said, "Hey, Chris, have you?" And I met him for brunch. I almost canceled. I was really stressed out because I had 3 proposals to write by that afternoon, and I thought, I don't know how I'm going to get this done. I do not have time to meet him. I need to cancel, and I didn't, because brunch. And I sat down with Ernie, and he said, "Chris, what are you doing with ChatGPT? You're a tech guy. Surely you're using it. And like, what have you done with it?" I said, "Nothing. I don't even know how to get in. I don't know how you get it. Like, where is it?" And he said, "Look, you got to do this. Look at this proposal that I just wrote." And this is a guy who can't retire, right? He's trying to retire, but he can't stop. And he had just used this thing to write a proposal, and he wrote a proposal that would have taken him half a day, even after 30 years of practice, in 25 minutes. And he had just described the problem set to the tool, and it had written a proposal that he tweaked a little bit, signed the bottom, sent it to a client. And I was like, it's weird that you suggested that as the problem that you had solved, because that is exactly the thing that I need to do 3 times this afternoon. And it's really stressing me out because I need to do that. And so that day I used ChatGPT for the first time to solve a real problem that I had. And so I think that that is what you need to have, is you need to have a problem that matters to you in your role that may be a fit for the tool. And probably any problem that you have may be a fit for the tool. So now you just need to have open-mindedness to try it and be willing to accept that. I've heard ChatGPT characterized as sort of an alien intern. And so it's an intern, so you don't trust the results, right? You're going to verify the results, right? It's an alien, so it doesn't think like you, so don't expect it to think like you. It wasn't just an alien intern. I'd heard it described as a drunk or a alien intern with a hangover. And so sometimes it's going to hallucinate, right? But that framing helped me sort of understand what to expect, right? That it's not going to be perfect on the first try. And so those things of like having the need and then having the expectations for the tool help me approach it and engage with it around not just that afternoon when I was stressed about getting the proposals done, but then every single day since then with a collection of tasks that I had where I ran up against this obstacle of saying, I don't have time for that, or that's going to take too long. And that could be initial data analysis of just like, I can't get Excel to build this graph that I want out of this. That spreadsheet's too big. I need to go and find this. I need to reformat this document and I just don't have time to wordsmith it. I need to draft an email and I have the bullet points, but like, oh, I don't have time to write it. Or it could be, I just need somebody to brainstorm with, right? So, and those tasks will change depending on the role. So there are some parts of our business where we've got not the LLMs, but a different set of AI tools that are being deployed that we've built internally to TT that are being used for concept design, right? Asterisk was one that we shared in the article. We shared a graphic of that are being used that we have built in-house around kind of pre-computed analytical results and other methods that are in the onion that our teams are using to get to first pass results quickly. So depending on the role, you may have different models, but you've got to approach it with like spot your internal kind of task resistance and be open-minded that the results are going to be wrong and be skeptical.
Well, I think that's a great overview, Chris, of what you're seeing, and that broad impact is definitely something that I've seen as well in our practice. From the whole, from kind of the nerds, I'll call them, who like myself, who like to spend a lot of time. I think all of us probably fall in that category, who spend a lot of time playing with tools and trying to use them to help us solve problems. I mean, we've been doing this for years, right, in structural engineering. To those who maybe aren't as comfortable with these technologies and are just kind of getting their feet wet. But I want to pivot to a topic on that note that I think is really important and something I'm even seeing in the Q&A right now, which is, if I'm a student, I'm a young engineer, we've had for many years a process of teaching, of internship, of apprenticeship in our practice that is changing pretty dramatically in the presence of even just the AI tools that we have available to us today, the GPTs, the search tools, the ability to access data and use it in a way that may or may not be verified or valid. MZ, I want to ask you this question. What does it mean to education? What does AI mean to education for students? And then Chris, I want you to kind of address what does it mean to the young professionals on your team? So MZ, what do you think?
Yeah, that's a great question. It's also something I've struggled with like a few years ago, but I think the easiest solution is the closest thing to what we're seeing now in AI is basically maybe when finite element started. Like when the first softwares started at those times, like let's say 70s, 80s, those softwares were not, as comparable to what we have now. Like if there are a few papers that go over the history of FE softwares, and authors clearly mentioned that when they go to conferences, nobody would attend their sessions, or like they would make fun of that like weak convergence, or like the very similar elements they had at the time. At this point, when you think about AI, those tools are, you know, they have their quirks and they have their issues, but the exponential growth of them is so high that they're being fixed almost at the moment. So, you know, we know they're gonna have some hallucination issues. We know they're gonna have some verification issues. Maybe the math that show up, they show the equation, they don't do the math correctly. But in academia now, we actually ask the students to use the tool and identify where the tool actually falls or fails, and then go back and try to fix it. So for instance, when they use ChatGPT to solve a homework problem, the GPT will say, you know, this is the key, this is the solution, these are the numbers I have. So if you don't do the math by hand, you won't know where the problem is. So in a way, it helps them to understand. It also helps them to figure out, okay, this tool has some merit and it also have some limitations. And without me personally doing the work by hand, I won't really learn. So I can't just give a homework problem or like a design problem to an LLM and expect to solve it for me without me knowing the principles. So I think it works both ways. And if they didn't really try it themselves, it becomes like a way that like a shortcut that we're trying to avoid. But as long as we educate them on what's the right way to use it, I think that'll be substantially helpful for all of us.
Yeah. I think in practice, and I don't know that we're, you know, certainly in our firm, we've been kind of experimenting in lots of different ways on this, but I think that these tools have the potential to bring more expertise to the younger engineers more often. And by that, I mean, we can and have experimented with sort of building chatbots around some of our most experienced staff, right? So this is along the lines of kind of the Reid Hoffman chatbot that we saw in the second webinar in the series, right? Is that within TT, we built a similar thing around one of our kind of welding experts within the firm, who was like, he was the guy that you went to who knew everything there was to know about welds. And we kind of built a chatbot so you could ask him questions even when he wasn't there. And as we restructure kind of data in the organization, you will be able to ask kind of the corpus of project history and models that we've built in the firm questions around, does this structural quantity for this hospital that I have just designed as a first-year engineer smell right? Right? Is it about right? And I can do that sitting at my desk before I tracked on kind of my project manager and schedule a meeting or whatever. Like I can get a sense for, does this feel right, what I'm getting before I go? Does that mean you don't need to talk to your project manager? Of course not. But it means that you can get sort of a tighter feedback loop and just get a sense of like, is this right? Or is there something else I need to check here? And at the minute, that's kind of, that's looser. And so I think in practice, these tools have the ability to like not only let us learn, tap into the knowledge that we have, you know, kind of at a meta level in the firm, but also to let the junior engineers tap into that and learn from it and get a sense of, am I on the right track very quickly, without having to go through the feedback in the expert. And then there's the chatbot, like actually getting a direct interface with kind of the knowledge that exists in our emails because we can interact with it in a different way. And the other thing that it does is it also brings, to MC's point about kind of the programming knowledge, is that it also means that maybe it changes the skills that we need to train. Like we just last year, I think, maybe even 6 months ago, we were talking at Structures Congress about how do we train our staff to be developers? Maybe that doesn't matter anymore. Maybe we don't even need to do that because, you know, we had on my team, we had a need where I needed a graph that was complicated. I knew MATLAB could do it. We could create it in Python, but we didn't know how to make the code in Python to do it. So we just we described what we wanted to ChatGPT, and it gave us the Python code that we then could tweak. And that was it. And it was amazing, right? It was like, so we could tweak it once we had it in our hands, but we couldn't write it to begin with. And, you know, that times 100 is going to be where we're at. And you can learn by having a great tutor in your pocket. So
it's interesting.
Fundamentally changing the skill set. It's,
Yeah, I hear a very hopeful vision there, Chris, which is not unexpected for, for how these tools can be can be leveraged for education. There's a lot of questions in the Q&A that I'm seeing, and we'll get to a few of those in a second, on hallucinations, on, error, how AIs and the GPTs can be prone to errors when you ask them questions. I think I told you guys a story. I mean, if anybody wants to try this, go into Copilot or whatever your favorite LLM is and type in, draw me the moment diagram of a continuous beam with 3 spans that's has a uniform load on it. Just see what you get. And it's kind of funny. I get some very unusual and unexpected results. But that's because I just used the internet for that ask. I didn't use the database of everything that Thornton Tomasetti or WSP or Clemson University has ever produced. Right. And that data is more and more becoming available. It's verifiable data. It's validated data. And I think it just speaks to, and this is in response to part of the questions, it speaks to the importance of the engineering validation that can occur in tapping into the expertise of those who are knowledgeable. Do either of you think that this will create a skills gap? Do either of you think that this can have the risk of creating a gap in necessary skills? So what happens when those experts retire and they're no longer practicing? Are we just going to rely on their uploaded knowledge to the internet or to the cloud to validate this information? What do you think about that, MZ? How are you addressing that in your class or your research?
That's a great question. I think the closest thing that comes to me is, if you think about the building code has been there for generations and decades, and senior knowledgeable people like keep knowledge there, and we have committees, and it continues to be verified and grows from there. Even if senior engineers like retire, the knowledge is still there. It's great to work with somebody who's very knowledgeable because you get to learn firsthand, but like not all of us have access to them. With much more information now, I mean, verifiable information, of course, I think it becomes a little bit exciting that maybe everybody will get access to the same level of knowledge in a way, maybe in the future, that it's not maybe accessible at the moment, but it's always going to be tricky with new technologies. I mean, we're just touching this right now, and I know maybe in the next 2 to 3 years, everything will be much more accessible at a much more faster rate, which much more verifiable information. My worry is that the data would be like the new oil. So like only small percentage of firms or companies or societies will only have access to it. But I'm hoping that everybody will get access to it very nicely and neatly. So maybe it may not be as serious as it is at the moment, but I think it's a great question to think about.
MZ, I think that's in the kind of the intro matter. That's why the global context matters, right? Is that many of the firms in our industry will operate kind of in projects that span national boundaries. And with these tools that we're starting to use, national boundaries matter, right? It used to be that for some of the tools that we were using, it only mattered, where your vendor was only mattered because you might pay a premium in your license cost. But now it matters because of data sovereignty issues about where does the data live. But it may also matter because there are major sort of policy implications into kind of how available that tool is in the long run, right? If it's a vital part of your business. And that's something that, like, as engineers, like, we're not used to having to pay attention to those things. But the more it becomes critical to your business, the more that becomes a new risk. And I think that's something that, it's interesting because as the more junior engineers use these tools, I think the closer that they are to kind of what Malik calls like the jagged edge of AI, right? Which is where there is risk. It's where there is opportunity, but it's where there is risk for the firm. and we're sort of used to thinking about the junior engineers kind of being kind of insulated from firm risk and not part of those conversations and that. But the more that the junior staff are using these tools to make design decisions or using them as part of the design and helping develop them, the closer they are to kind of adjusting the firm's risk profile. And we need to really be engaged in that process. Yeah, it's very interesting.
Well, whatever it is, it's going to be a wild ride over the next few years.
You got that right.
As he's pointed out to us, no matter what we think now about the AI tools, and it's easy to trip them up, right? It's easy to, I think a lot of people have fun just, like that example I just described, trying to show how much smarter you are as a human engineer than the AI. But what that belies is the disruptive and exponential improvement of the AIs that's going on in the background. And I think one of the core issues with improvement of the tools to get to like true agentic, as they're called, AIs that can actually reason and solve problems and create new solutions, not just kind of regurgitate to you an answer from a book that a search engine could do before. Really must focus on what is the data that is being used to train the model. Machine learning is about, deep learning is about the data, training on validated data. I wonder if each of you can speak about that, maybe MZ from the perspective of where's that data going to come from? And then Chris, maybe a little bit about intellectual property. Our firm's going to hold that data close, and is that something that's something a lot of the audience is interested in, just judging from the Q&A.
Yeah, thank you, David. This is actually a very good point. And I'm glad you mentioned reasoning, because we do need like a large amount of data to train AI, whether it's like an LLM or a different type of a model. But I think once we start to, and this data, of course, comes from multiple sources, like the internet, some nodes, some books, some maybe verified, some maybe just like forums, maybe from out of Reddit, somebody's just pulling something. But I think once we start to think about, or I'm sure there are like some research that goes, we could actually train or build AI tools that reason. And if we get to that point where they can actually reason, then maybe we don't have to emphasize the data as much, because if they can reason like at a higher level, then they won't need as much data to be trained at, and they could like have maybe like a chain of thought kind of a process where they break things into smaller pieces and they go from there, like just like how we think about first principles, theory, derivation. We start with boundary conditions and we build from there. Maybe they'll be able to do that, and then the problem of data hallucination gets a bit smaller with time. But at this moment in time, I think we're a little bit far off that level. So we're gonna have to rely on data, and I'm interested to see what Chris is gonna say about IP, because this is a big issue for the industry for sure.
Yeah. So IP is the concern, right? I mean, there are both intellectual property issues about how widely can you share the data that you hold about any given project. There are going to be firms that work on restricted projects, right, that have information handling requirements because they have government clients or have other sensitivities. And then there's just the what aspects of my design am I willing to share? And this is where as you use tools that learn from that data, you've got to be thoughtful around where's the data housed, that I was hinting at with the sort of data centers and data sovereignty issues about within what national boundary is it. But what can I share and who benefits from that? I think that each firm will have to find make its own decision around how much of these tools do you build in-house versus what do you leverage third-party tools for? To what extent are you a consumer of tools versus a creator of tools? Within Thornton Tomasetti, we are both, right? There are certain, this is why I was kind of describing the answer to every question depends on the role you have and the problem set that you're solving. So it gets complicated quickly. So you have to have a policy to describe this within your firm, right? You have to make a decision to guide your staff to help them navigate these issues. But if can you use ChatGPT for firm work, or any other LLM, right? Can you use these tools? Will the firm provide it? Can you use the third-party tools? If no, then you're sort of committed to building them internally, which is possible. It's just a different level of investment. It's a different level of skill that you have to have, but it also kind of keeps your IP in-house and requires you to build those capabilities. I think at the minute within TT, we're both a consumer of LLMs and we're adapting LLMs to build the chatbot that I mentioned, that kind of expert system. And we've done some of the machine learning processes to develop that tool called Asterisk that I mentioned. And that's been, but this has been as part of our kind of core lab program, as part of Core Studio, right? This has been really a kind of culmination or continuation of a multi-decade long investment in this space, right? So this isn't something that we just started. But it's kind of find the right tool set for the right job. And I think that the approach that we've taken is where we can buy the tool and we're comfortable and it's consistent with our AI policy, we will do that because it's more cost effective to do so. For the problem sets that are very specific to structural engineering and analysis, where we cannot buy them, then we will build it if we feel like it is cost effective and it's a net benefit to the firm to do that. And that's kind of what you see represented in what we shared in the article and what I've discussed.
Well, I think this also speaks to the work that we can do as a profession through ASCE, NCSEA, and CASE, which is where we convene as professionals to advance the practice and kind of address some of these challenges. I can tell you that ASCE is introducing machine learning or GPT tools into its publications through the ASCE Amplify platform. That's something some of you are maybe in the audience and even some of the panelists have been working on. There's a lot of research and work going on in the background for how we can take our standards and use them to train intelligent models that can really leverage them for the profession. But that also brings up the challenge of like, well, that's intellectual property, or that's those publications are how our organizations persist. It's how we finance ourselves. It's how we get to have great seminars like this. So this is a challenge that we all have to work on together. I think that's a really important outcome of this. But I just want to put a couple of questions up that the audience has posted. Unfortunately, we won't be able to answer all of them live, but I've tried to bring in some of the questions into our discussion here. One that I've seen a few people ask, I'm just going to bring them up right now, is related to how do I get started with AI? I'm Sundar Sham, for example, asks, I'm a structural engineer focusing on technical aspects at work. What's a good starting point for me to dive in to learn more about AI? What learning should I focus on? Another question is from Bill. He says, like, how do we get started using AI? Do we need to buy a product, a subscription? Do we need some beginner instructions? How do we get into this? You want to take a crack at that, Chris?
I am still a beginner. Okay. Super duper beginner. So, and I can say that even as a panelist, right? I am still learning. Everybody in this space is still learning. So, I think that I think there are two sources to go to. One is the NCSEA website that I shared on the resources slide. They as part of an industry collaboration have put together some really, really excellent resources for structural engineers who want to apply AI to technical work, including some basic problem sets and training resources to bring AI into engineering work via machine learning and other mechanisms. Okay, so that is that's maybe not the first step, but that is if you want to use AI for technical work, that go there. They're constantly developing it. It's a really, really excellent resource. Okay, and it's evolving all the time. You can also watch, if you haven't already watched the first webinar in the series that kind of touches on this point, and read the article that walks you through the NCSEA kind of evolution of their outline for AI in the industry.
I'm gonna put up one more question. I'm gonna give this one to you, MZ. This is related to education. As an educator in structural engineering design and analysis, I'm curious to know the panelists' thoughts on content that should be included in a 10-week or 14-week undergraduate or graduate course. This is from Andre. What do you think?
Oh, I think it's a great question. I know we only have like a minute, so I'll do my best to answer it. But I think if personally, I would prefer focusing on the principles first. Like for instance, a simple beam, do it by hand, and then like do it by an algorithm just to see and compare. I'll focus more on those. If you would like something more in detail, if you go to my website, I have like the way I teach my course. You could just like copy it from there. It's freely open for anybody to learn. I do have like a few videos on YouTube too. You could just like skim through those and see the philosophy I follow, because it's very simple from there. And if you have any feedback, we would love to hear your thoughts on it. But I would always prefer simplicity, stay away from coding, anything complex, because the students would like to visualize. I'm a visual learner, and I take it like if I see it and I learn it, it usually sticks with me a little bit better.
Okay, I'm going to give the last word to you, Chris. I'm going to ask one more question here from the audience.
Okay,
and that is,
I just want to underscore that point that, you know, I think what these tools remind us to do is stick to first principles, right? And what is your core value as an engineer and as a human, right? So don't get too bogged down. As you adopt the tools, you're going to be challenged to think about first principles.
So on that note, we have someone asking, how do I increase adoption of AI in the firm? People expect things to be very accurate, or they're skeptical. What's your advice there, Chris? How do we get structural engineers using this tool in our practice? You have 1 minute.
You got to start with the challenging problems. Like start with the problems that staff feel like are not worth their time, which may not be the hardest design problems that you have. It probably will not be those, but it may be the more administrative challenges, right? It takes too long to fill out my time card. It takes too long to write meeting minutes. Get buy-in via the mechanisms where the stakes are lower, but you can get the habit of using the tools and get engagement. It's going to require conversation. It's going to require expectation setting on all parties, right? On the leadership, on the part of the staff. Again, if using this stuff requires you to think back to first principles of what does it mean to be an engineer and where is my core value, kind of as a human and in my role, I think what it also reminds us as we're doing this is like, it's like change management on steroids. So you've really got to have a lot of conversation up front about, well, period. You've got to have a lot of conversation up front.
Well, with that, I think I'll bring things to a close. I want to thank Chris and MZ for a really spirited discussion here. I think we're hopefully able to answer. I know we couldn't get to all the questions from the audience, but hopefully we're able to answer a lot of your core questions through our dialogue. And of course, I, for one, am really excited to see where things go next. This time next year, you know, I encourage everyone to attend the NCSEA Summit, attend Structures Congress, you know, get together and talk about these issues, because this is how we as a profession are gonna increase adoption and move the industry forward so that we can make a big impact on society. In fact, that's what we really want to do as structural engineers. And AI can be a really powerful tool for us to accomplish that.
Yes.
I'll turn it back over to you, Amber.
Yeah, great. Thank you so much, David, for being our moderator. And thank you, Chris and MZ. This has been great. Thank you to the audience for the participation and all the wonderful questions that you posed. On behalf of CASE, NCSEA, and SEI, thank you for your participation in today's webinar. And this concludes our joint summer series.